this is Mrs. Meyer. In this lesson, we're working on Standard 4.nf.7, comparing decimals. And in this lesson, students have to make sure they remember that they always start with the largest place to the left when they are comparing decimals. Sometimes we're going to have, oftentimes, there's going to be numbers that appear in the ones, the tens, the hundreds, the thousands, on and on places in a place value chart. But with this standard for NF7, we're focused on the actual decimal places, the tenths and the hundredths, and students realizing which of those is greater, okay? And looking to see if they're equivalent in those situations. So if we were going to compare 68 hundredths, let's say with 7 tenths, okay? And students always want to use the greater than, less than, or equal to symbols, of course. Okay, so when we're talking about always working on the, always go to the largest place to the left that appears in your decimal numbers. So if we're looking at that situation, we're going to see we have the ones place here. In the ones place, that's just the largest places that we have in these two decimal numbers. But again, our focus is on the actual decimal places, not the whole numbers. Okay, so, and we see that the ones place, since they're both equal, I can't judge the number by just that place alone. I must go to the next largest place, which will be the tenths place. And I go there and I see I have a 6, and I see there's a 7. And so that's why students must follow the steps, because if they just look at this number, they're going to say, oh, 68. Oh, 68 is greater than 7. So therefore 68 hundredths must be greater than 7 tenths. And that's where students have to learn the value of each place in the place value chart to learn the value. The tenths has a greater value than that of the hundredths. So therefore, once they master that skill, they're going to know that 6 tenths is actually less than 7 tenths, because this is the same as 68 pennies, basically. That's what I tell students, is that hundredths are like pennies and tenths are like dimes. It takes 100 pennies to make $1, and it takes 10 dimes to make $1. So 68 hundredths is 68 cents, whereas 7 tenths or 7 dimes is like 70 cents. So if they think of it that way, and I always also tell students they can always add a 0 to make any one-digit decimal into a two-digit decimal. So it makes it much easier to compare just visually looking without going place to place, but I still want them to go place to place to always be sure that they're accurate. But in that situation, they can see that, oh, 68 hundredths is less than 70 hundredths because 6 tenths has a smaller value than 7 tenths. So therefore, 68 hundredths is less than 7 tenths. And just that little, back to the first grade saying, the big mouth eats the big number, so the opening of the greater than, less than sign is always open towards the larger number. Okay, so in that situation, it's 7 tenths. Okay, so we can try that again. So if we have, for example, 9 tenths, we want to compare that to 91 hundredths. Okay, let's look at that. So if we go look at each place, we see that we have the ones place again. We have both a 0. Go to the next largest place, which is the tenths place. I have a 9 and a 9, so I gotta keep going on this one because they're still both the same. I go to the next largest place. Oh, wait, there's nothing there. When nothing is the same as 0, you can always put a 0 to make them both two-digit decimal. So I have a 0 and I have a 1, which is greater. I know the 1 is greater. Therefore, 9 tenths is less than 91 hundredths. 9 dimes, 91 pennies. Very, very close to being exactly the same, but yet 91 hundredths has a greater value. Okay, so, and also students also need to realize the situations where they are equivalent. So for example, if we have this, okay, and they go to the ones place again, they see both a 0, go to the next largest place, which is the tenths, and they see they have a 5 and a 5. Just got to keep going to the hundredths place. There's nothing there, and there's a 0. Well, they can't forget that nothing there means it's the same as a 0. Can always put a 0 in the hundredths place when it's comparing a two-digit to a one-digit decimal. And now I know that 5 tenths is equal to 50 hundredths. Hopefully this lesson has helped you in helping your child to walk through the steps of doing two-digit decimal comparison. In this lesson, we're working on standard 4.nf.7, comparing decimals. This is one of a little bit simpler skills of all the things that expectations of fourth grade students. Let's just jump in here with an example. So if we have, let's do a decimal that has whole numbers as well. So let's do 1.58. We'll do our circle to compare. We're going to use, of course, greater than, less than, or equal to. So 1 and 5800ths, greater than, less than, or equal to 1 and 6/10. Okay, so students are looking at these. Always tell them that we should always start with our largest place, and our largest place is always all the way to the left, whatever that may be. That is it can be the thousandths place, 10,000s, whatever place it is. That is the digit that we start comparing with. So I'm going to start with my largest place of these decimal numbers, and I see that my largest place is going to be the ones place. So I look here in the ones place. I have a 1 in both of those places. Okay, so I have to go to the next largest place and compare those two digits. Okay, in the next largest place, I see that I have a 5 here, and I have a 6 here. And so, and I also have told students that tenths are like dimes and hundredths are like pennies. So if we're talking about dimes, 5 dimes and whatever miscellaneous number of pennies it may be, in this case it's 8, is always going to be less than if we have 6/10, which is like 6 dimes. So, and I always again tell students that they can always add a 0 here in the hundredths place, and that makes it a 2-digit versus a 2-digit, and they should know that 1 and 5800ths is less than 1 and 6000ths. So we can see that by not only using common sense thinking by putting the 0 there, but also by just going from largest place to smallest place. And so if we did another one, if we did 2.34, and we'll compare that to 2.39. Let's compare these two. Okay, so in this situation, again, we go to the largest place, which would be the ones place. Here's the ones, here's the ones. So we see they're both a 2. Anytime they're both the same digit, you know you got to keep working your way to the right. So I keep working my way to the right. I have a 3, and I have a 3. They're both still the same, so I got to work my way even further right to our farthest place to the right, which is the hundredths place. So now I see a 4, and I see a 9. So, and we should be able to recognize right away that 4 is less than 9. So it's, you know, it's pretty much just following steps and making sure that you're working from the largest place. It could be, you know, 2-digit whole number with the decimal. If we had 25, we're going to compare that to 23 and 9/10. 25 and 9/900ths compared to 23 and 9/10. Again, we start with our largest place, which in this situation it is the tens place. We have a tens digit, so we have a 2, and we have a 2. We go to the next largest place, which is the ones. We have a 5, and we have a 3. And students should know right away that 5 is greater than 3, so therefore 25 and 99/100ths is greater than 23 and 9/10. Hopefully that was helpful for you to be able to help your child, but just the key to remember is to always start far left and work your way to the right, and that's comparing the largest place value to the smallest place value.